Hello, my name is Isabel Gilio. My presentation is on evaluating the effects of relocation versus in situ incubation on the hatching success of Kemp's Ridley sea turtles in North Carolina. Sea turtle populations around the world are experiencing significant declines due to a combination of environmental and anthropogenic factors, including pollution, overfishing, bycatch, and coastal destruction. Among the most endangered sea turtle species is the Kemp's Ridley, which holds the distinction of being the world's smallest and most critically endangered sea turtle. The majority of Kemp's Ridley nesting occurs along the western shoreline of the Gulf of Mexico. The most crucial nesting site is located near the village of Rancho Nuevo. From 1947 to 1960, the Kemp's Ridley was the most abundant sea turtle species in the Gulf of Mexico, with a synchronous nesting emergence event known as an arrabada occurring annually. During this unique nesting event, which takes place from April to July, large groups of females gather offshore and come ashore simultaneously to nest. After an incubation period of 45 to 58 days, depending on temperature, the hatchlings will emerge. And this synchronous emergence increases hatching survival and success by reducing predation risk, as the abundance of hatchlings makes it difficult for predators to consume all of them. Due to intense fishing effort during the 1980s, the Kemp's Ridley nesting population had reached a record low of only 702 nests, likely due to bycatch complications. To protect the Kemp's Ridley from extinction, a secondary nesting colony was established at Padre Island National Seashore in North Padre Island, Texas, which remains the primary location for Kemp's Ridley nesting. Conservation efforts focused on protecting nests by relocating clutches from their original threatened sites to more secure locations, such as hatcheries or elevated regions of the beach. These relocated nests are secured with corrals, cages, and metal or mesh coverings. This strategy safeguards developing eggs from threats such as predation, tidal fluctuations, storms, elevated temperatures, marine debris, and anthropogenic activities such as poaching and vehicle disturbance. Although these protective measures have contributed to the recovery of the species population, some critics have raised concerns about the relocation and protected incubation of clutches as conservation strategies. Nest relocation is controversial because altering the location of clutches can impact hatchling fitness and sex ratios. Like all reptiles, the sex of sea turtles is determined by the incubation temperature of the eggs. Under natural conditions, following a temperature-dependent sex determination regime, sex is typically balanced in a 1-to-1 ratio, with the production of females and males in equal numbers. Cooler temperatures produce males, while warmer temperatures produce females. Disrupting this natural process can influence the reproductive ecology and long-term recovery of the population. Moreover, modifying the natural incubation environment may affect hatchling morphology, including scoop pattern, locomotive performance, fitness, and overall viability. In recent years, small numbers of Kemp's Ridleys have been observed nesting along the shorelines of North Carolina, outside their historical nesting range. This behavior has been increasingly common as water temperatures continue to rise in northern coastal areas during the spring. Management strategies for the species in North Carolina have involved both the relocation of clutches to safer incubation locations and modifications to in situ nests. This study aims to evaluate the effects of relocated versus in situ management measures on Kemp's Ridley clutches, focusing on factors such as hatching and emergence success. Understanding these effects will provide valuable insights for researchers and conservation programs in North Carolina, helping to determine the most effective approaches for the recovery of the species. I hypothesize that relocated clutches will exhibit higher hatching and emergence success compared to in situ clutches. The data for this study was provided in an Excel spreadsheet containing detailed information on Kemp's Ridley nesting from 2003 to 2024, which was given to me by Dr. Matthew Godfrey of the Duke University Marine Lab. This data was then imported into ArcGIS Pro for analysis, where I made a map, which can be seen on Figure 1. In total, there were 18 relocated and 49 in situ nests. The average hatching and emergent success for each group was computed by dividing the total hatching success by the number of nests in each group. Then I observed various factors of incubation, including unhatched eggs, dead hatchlings, live hatchlings, washovers, and predation to assess the impacts on overall hatching and emergence success. I then calculated the average incubation period and hatching success and relocated versus in situ nests, which were grouped into 3 categories based on the length of the incubation period, which include greater than 60 days, between 55 and 60 days, and less than 55 days. Looking at Figure 1, we can see that the most frequently visited nesting site was Cape Hatteras National Seashore, with 30.5% of the total, followed by Cape Lookout National Seashore with 18.3%, and Nest, or the Northern Outer Banks, with 12.2%. Looking at Figure 2, we can see that on average, both hatching and emergent success rates were higher in relocated nests compared to in situ nests. The average hatching success for relocated nests was 68.99, while in situ nests had an average hatching success of 54.11. This indicates a 27.5% higher success rate in relocated nests. Similarly, the average emergent success for relocated nests was 56.24 compared to 50.09 for in situ nests, reflecting a 12.3% higher emergent success in relocated nests. Looking at Figure 3, we can see that hatching success decreased with longer incubation periods. Nests incubating less than 55 days had the highest success. These nests had an average incubation period of 50.9 days in relocated and 50.6 days in situ, with relocated nests achieving an average hatching success rate of 75.9 and in situ nests showing an average hatching success rate of 83.5. Nests incubating 55 to 60 days showed intermediate success, with average incubation periods of 56 days in relocated and 56.5 days in situ. The average hatching success rate for relocated nests was 73.6, while an in situ nest had an average hatching success rate of 66.8. Nests incubating greater than 60 days had the lowest success. These nests had an average incubation period of 67.5 days in relocated and 66.5 days in situ, with relocated nests showing an average hatching success rate of 46.8, while in situ had an average hatching success rate of 58.7. Looking at Figure 4, June was the most active nesting activity month, accounting for 67% of all recorded nests laid from 2003 to 2024, followed by July with 19% of nests and May with 14% of nests. My hypothesis was supported as relocated clutches exhibited higher hatching and emergent success compared to in situ clutches. On average, relocated clutches demonstrated a 27.5% higher hatching success and 12.3% higher emergent success than their in situ counterparts. These differences are likely attributable to the enhanced protection afforded to relocated clutches, shielding them from threats and environmental stressors